Hello, algebra students. We're looking at Chapter 3, Lesson 6 this evening, solving word problems using charts, and we want to complete 5-step problem-solving process with complex equations, and we're going to use charts to help organize ourselves. So that's the template you would like out, and we're going to start with a couple of warm-ups. So for this first warm-up, we're going to write and set up an equation only. And so that means we're just going to read the problem, set it up, write the equation. We're going to skip the solve and sentence part. So Hillary has 3 times as much money as Paul. Jeff has $4 less than Hillary and 5 more than Paul. How much money does each have? So we want to read it. We want to set it up, which includes defining our variable. And I like to look through and say, okay, what do I know the least about? And that's what I'm going to put as my base variable. So I know a little bit about Hillary. She's got 3 times as much money as Paul. I know that Jeff has $4 less than Hillary and 5 more than Paul. So what I know the least about is Paul's amount of money. So you could use X or really any variable, but I'm going to use P because it reminds me what I'm looking for or what the variable stands for. And so that's going to stand for Paul's amount of money. And then I want to define the others as well. Like if I have Paul's, then I want to decide, okay, what is Hillary? Hillary has 3 times as much money as Paul. So hopefully thinking through, you can define that as 3P. So that would be Hillary's amount of money. And Jeff has 4 less than Hillary and 5 more than Paul. So we could define Jeff's money as P plus 5, or we could define Jeff's as 4 less than Hillary. So we could say 3P minus 4. And that's Jeff's amount. And the idea that Jeff's amount of money doesn't change in this situation, that those things have to be the same. So that gives you the equation that 3x minus 4 has to be the same as, which is equal to I guess I should make that P. There we go. P minus 4 is the same as P plus 5. So for the next warm-up, again, we're going to write the setup and an equation only. So you're asked to find 3 consecutive integers whose sum is 15 more than twice the middle integer. So our setup is that 3 consecutive integers. So our first integer, we can make x. Our second, since they're just consecutive, not consecutive evens or consecutive odds, is just x plus 1. And then our third would be x plus 2. So that's our beginning of our setup. We want to, defining our variables, we want to write our equation. So 3 consecutive integers whose sum, so that means I'm adding the 3 consecutive integers. So that's x plus 1 plus x plus 2, and the sum is, so that's equals 15 more than, so I'm adding 15 to something. It's 15 more than twice the middle integer, and the middle integer is x plus 1. So just taking it phrase by phrase to write that equation. Now for example 1, we're going to organize things into a chart, and then we're going to write the equation. So we have a roll of carpet 9 feet wide. It's 20 feet longer than a roll of carpet 12 feet wide. The second roll has a perimeter of 54 feet. So we want to show this setup and equation in 2 ways. So we set up a chart. We've got lots of information here, so setting up a chart to organize ourselves. So we have a first roll of carpet and a second roll. So we want to make sure we have a spot for information for both of those. And then the other thing we're talking about with the carpet, in regards to the carpet, is the length and width. So we want categories for that as well. So reading through, we've got a roll of carpet 9 feet wide, so that would be 9 feet in our first roll's width, and that is 20 feet longer than a roll of carpet 12 feet wide, so the other roll is 12 feet wide. And we can say, okay, if that roll of carpet that's 9 feet wide is 12 feet longer than roll of carpet 12 feet wide, then if that is X and it's longer than the other one, then the other one would be X minus 20. Now that may not be how you thought it through, so let's look at the other chart. Again, we have our first roll and our second roll, and our length and our width. And of course the width is going to be the same. That first roll is 9, second roll is 12. And you may have thought about, okay, that the first roll was 20 feet longer, so that's going to be, plus 20. If the second roll is X, then the first roll is X plus 20. And you can look at that either way. It's just going to depend on which approach what your equation looks like. So let's go back to the first one and think through that. So our equation comes from the fact that the second roll has a perimeter of 54 feet. So we're looking at a rectangular perimeter, and so we know that perimeter is 2 times the length and 2 times the width. So in this first scenario, we're looking at 2 times X minus 20, and we're going to add 2 times 12. And this is going to give you what you're looking for here, because you're going to solve for X. What you're looking for in this one is the length of the first roll. So the reason we can use a different equation here is we're going to be looking for different things. When we solve this first scenario, we would be finding the length of the first roll, and we would have to go back and find the length of the second roll. Now in the second situation, so looking at the second table, again, that perimeter of the second roll is 54 feet, so 54 would be equal to twice the length. This time that's just X plus twice the width. And the reason this works as well is because we're looking for a different thing. This time we're looking for the length of the second roll. And so if we solve this, we would get the second roll. We'd have to plug in and get the first roll. So 2 different possibilities of setups there. Either one works as long as you keep track of what you're looking for. Right, for this next example, we'd like you to organize the given information into a chart. So I'd love for you to pause the video and see if you can organize this one board problem into a chart, and then start the video and check what we have. So one board is 4 inches wide and 8 inches longer than a board 2 inches wide. So we've got 2 different boards, so I want spots to organize that. First board, second board, and the other things I'm considering are the width and the length. So one board is 4 inches wide, so that's going to give me 4 for the width, and 8 inches longer than a board 2 inches wide. So the other board is 2 inches wide, and I don't know how long the other board is, but I can define that as X, and then it says the first board is 8 inches longer than that, so that would be X plus 8. So the chart is really just helping us organize and define our variables. For the next problem, we've got Jess bought some boxes of lemonade at 70 cents per box. He bought 8 fewer boxes of punch at 60 cents per box. So this time we're looking at two different drinks here. We've got lemonade and punch. So we want to organize that. And we're considering three different things here. We have the number of boxes. We have the price. And the total cost for each. So he bought some boxes of lemonade, so that would be your X, and it was 70 cents per box, so we're looking at the price of 70 cents, and the cost for the lemonade then would be 0.7X. We've got the punch. We know that he bought 8 fewer boxes, so that would be the lemonade boxes minus 8. We know that the price of the punch is 60 cents per box. And so the cost of the punch would be 0.6 times X minus 8. So again, just using that chart to kind of organize all our information. For example 2, we've got a pear contains 30 calories more than an apple. 10 apples have as many calories as 7 pears. We want to find the number of calories in an apple and in a pear. Now, when we're given our information, we're given the pear in relation to the apple. So we want to make X our number of calories in an apple. And that's because we know more about the pear. So we want to make our unknown what we know the least about. And so we don't have the information for the calories per apple. We know that the pear is 30 more than the apple. We know that we have 10 apples and 7 pears. And the calories per fruit is going to be times the number of fruit is going to be our total fruit calories. So the apple calories would be 10 times X, and the pear calories would be 7 times X plus 30. And because the calories in the apple, 10 apples is the same as 7 pears, we can set up the equation as 10x is equal to 7 times x plus 30. So we solve that equation. Start with my distributive. And then subtract 7x from both sides. And I get x is equal to 70. So I know that's the number in an apple. So there are 70 calories in an apple. And then we have to go back and plug in. So we know that the pear is x plus 30. So we would do 70 plus 30. And so that gives us 100 for the pear. So, and 100 calories in a pear. So in example 3, we've got tickets for the senior class play costing $6 for adults and $3 for students. A total of 846 tickets worth $3,846 were sold. How many student tickets were sold? So we're looking for how many student tickets. So X is going to stand for the number of student tickets. Because that's our unknown. All right, so let's organize our information into a chart. We've got student tickets, and we've got adult tickets and prices, and we're looking at having the number of tickets and times the price of those tickets would give us the cost or the total money amount for both student and adult tickets. So again, our student tickets are X. We don't know that. Our adult tickets and student tickets are different prices here. So student tickets are $3, and so the total cost for that would be 3X. We know that there was a total of 846 tickets, and so the adult tickets would be the difference between those. So we can say adult tickets are 846 minus the student tickets, and the price of the adult tickets is $6. And so the cost of all the adult tickets together would be 6 times 846 minus X. And so we're looking at, the other amount being, that's that 846 minus the X. So our equation, then we take into account that we sold 846 tickets and that it was worth $3,846. So the costs of the student tickets together with the adult tickets gives us our equation. So for our equation, we have 3X for the student ticket money plus 6 times 846 minus X. And when we put those values together, we get their total fundraising, which is $3,846. And then we solve. I'd like you to pause the video and solve that equation. Hopefully when you solved, you got 410. And so we're looking at the student tickets being 410. So, and that's what we're looking for. We're just looking for the 410. You could plug in and find the adult tickets, but we weren't really looking for that. And so there were 410 student tickets sold. We're going to do one more example together here, example 4. We have a collection of 40 dimes and nickels worth $2.90. How many nickels are there? So we're looking for our number of nickels, but we've got a collection of 40 dimes and nickels, and you can determine whether you want the dimes or nickels to be X. Now, because we're looking for nickels, I think I would choose for that to be the number of nickels. And again, because that's what we're looking for. And, how do we find the other amount? Well, if we have 40 total coins, then if X is the number of nickels, then the dimes would be equal to 40 minus X. And so we're going to organize our information here. We have nickels and we have dimes. We have the number of coins that we're counting. And we have the value of those coins, how much each is worth, because we are taking that to an account with the dollar amount. And if we take the number times the value, then that gives you the total value of both like nickels and dimes. And so if our X is the number of nickels, and we said 40 minus X would be the number of dimes, a nickel is worth 5 cents. So I'm going to say 0.05. And so the total value of all the nickels would be 0.05X. A dime is worth 10 cents. And so the total value of the dimes would be 0.1 times 40 minus X. And we know that together their values give us $2.90. So I can take my 5 cents times X plus my 0.1 or 10 cents times 40 minus X, and if I add those values together, I get my whole money amount, which is $2.90. And then I want to solve that equation. Again, pause the video, see if you solve, and then check in and see if you get a match. So hopefully you got x is 22, and that's what we were looking for. So not much to plug in. Now if you had defined it the other way, where the dimes was x and the nickels were 40 minus x, you'd have to plug in to find the nickels. There are 22 nickels. So you have examples 5, 6, and 7, and we'd like to see you complete those on your own and bring them into class. Of course, writing down any questions, but try to organize your information into a chart and then use that chart to build your equation and solve. So again, we're expecting examples 5, 6, and 7 to come in complete and you with your questions.